Welcome to our review on the transition metals. So first of all, we need to know where to find the transition metals on the periodic table. And they're quite easy to find. They're those blocked between groups 2 and 3 on the periodic table, so the low bit if you like. As their name suggests, they are all metals. It's not just a trick, so where it says they're transition metals, they genuinely are all metals. And as you might expect from things that are metals, they actually have a lot of properties in common with those metals that you are very familiar with, because those metals you're familiar with actually occur mainly in the transition metals if you look. So they're shiny when freshly cut, they're good conductors of electricity, they're strong, they're malleable. All of those are properties you should associate with metals. One of the things you might be asked to do is to compare the group 1 and transition metals and their properties. So if we do that, then the transition metals are stronger, they're harder, they've got a higher density, and they've got a higher melting point than those metals that we find in group 1. If we now think about the chemical properties of our transition metals, then the first and most important fact to remember is that they react really slowly if they react at all. Now, a good example of transition metal is iron. Now, you are probably familiar with one very slow reaction of iron, where iron will react with oxygen and water to make hydrated iron 3 oxide, or as you probably know it, rust. So that's a very slow reaction. It doesn't happen overnight. It's not like if you leave something made of iron outside for 24 hours, you go back and it's just a pile of rust. This takes a really long time, so it's a very slow reaction. If you consider some of the other transition metals, like platinum for example, then they don't react with water or oxygen. And it's because of that fact that we use those transition metals that are unreactive for things like jewellery. Otherwise it would be a really sad day if someone just bought this lovely platinum ring, washed their hands for the first time, and then the ring was gone. So we're picking things based on their chemical properties. Because the transition metals generally don't react, then they're really good for things like jewellery. The next thing we need to consider is the fact that the transition metals are actually kind of cool, because what they're able to do is they don't just form one type of ion, like those in group 1 always make a +1, those in group 2 always make +2 ions. They can make more than one type of ion. Now, it could be a little bit tricky to identify what type of ion you've got, but when they're writing out the names, the little number in brackets in Roman numerals tells us the charge on that metal ion. So if we've got iron with the 3 in brackets there with Roman numerals, oxide, then we've got Fe3+ ions. If it was a 2 in the brackets, it would make Fe2+ ions. So whatever the Roman numeral in the brackets is, tells you the charge on the metal ion. The next thing that's really nice about the transition metals is they're not dull when they're in their ionic compounds. These actually make some really pretty coloured compounds, and you can see them in that picture in the centre there. So you get purples, blues, greens, this whole array of different colours with the transition metals when they form the ionic compounds. If we compare that with the alkali metals when they're in their ionic compounds, they're not quite so exciting. They're either white or colourless. So if you want pretty colour chemicals, then you need to look at the transition metal compounds. Another feature about our transition metals is they are good catalysts. Now hopefully we remember that a catalyst is something that's able to speed up a chemical reaction without being used up itself. So they're great to use in industry where we want reactions to happen as quickly as possible. So you add one of these catalysts that's suitable for the reaction and it makes it happen faster. And we'll look at how that happens in a later session. There is one place that uses these transition metals that you may well use every day of your life, which is in cars. So some cars have something called a catalytic converter as part of their exhaust system. And the whole idea behind that is to convert harmful exhaust gases into less harmful ones before they're released into the atmosphere. And what we're actually doing is in that catalytic converter, we've got some of these transition metals. And it's things like platinum or rhodium or palladium. And as a result of them being present within this device, they're going to then help to convert those harmful gases you can see going in into the less harmful ones coming out. Hopefully at the end of this video we can now recall where the transition metals are, their physical properties and some of their chemical properties, as well as how we could actually use them.